Welcome to Astral Passage, where we journey through the mysteries of the cosmos. Today, we're diving into the darkest corners of space to explore the most powerful giants of the universe, the black holes that dwarf entire galaxies. Prepare to be amazed by the scale, the power, and the mysteries that these titans hold. In the vast, uncharted expanse of the cosmos, one thing towers above everything else. It's invisible and terrifying, and it can grow endlessly. We're talking about black holes, the universe's largest, most powerful objects. But what makes them so immense? How do they grow? And perhaps most mind-blowing of all, how big can they get? Today, we're not diving into how black holes work or how they form. If you want that information, check out our other videos on black holes and neutron stars. But here, on Astral Passage, we're on a mission to explore the titanic giants of the universe, the monsters of the cosmos, the largest black holes known to humanity. Let's start at the very beginning, with black holes that might not even exist. Primordial black holes. These hypothetical objects could be the oldest things in the universe, older even than atoms themselves. They would have formed in the earliest moments after the Big Bang, when the universe was dense and chaotic. The conditions were so extreme that a tiny, dense pocket of energy could collapse into a black hole, possibly as small as a proton. Imagine a black hole with the mass of Mount Everest, but no bigger than the head of a pin. That's a primordial black hole for you. These objects, if they exist, would be nearly impossible to detect. But they may very well make up the mysterious dark matter that holds galaxies together. But let's get a little more tangible now. Stellar black holes are the most common type, formed from the collapse of massive stars. Once a star collapses in a supernova explosion, its core can implode under its gravity, creating a black hole. The smallest known stellar black hole is 2.7 times the mass of our Sun. Its diameter? About 16 kilometers, enough to cover the city of Paris. On the other hand, some stellar black holes can be much more massive, like the one at the heart of the galaxy M33, which weighs in at 15.65 solar masses and has a radius of 92 kilometers. These black holes grow by consuming nearby stars, and sometimes they merge. Scientists recently detected the merger of two massive black holes 17 billion light-years away, releasing more energy than the combined light of every star in our Milky Way for over 4,000 years. Now let's move to the big leagues. The supermassive black holes at the centers of galaxies are true monsters. The one at the heart of our galaxy, Sagittarius A star, is about 4 million times the mass of our Sun. But even though it's massively powerful, it's only 17 times the radius of our Sun. Its gravity doesn't keep the Milky Way's stars in orbit. Instead, it's the mysterious force of dark matter that holds our galaxy together. Some supermassive black holes, like the one at the center of the Lacerta galaxy, are actively feeding. These hungry giants produce jets of plasma that accelerate to nearly the speed of light. If Earth were orbiting this behemoth, it would appear 115 times larger than our Sun in the sky. And don't even get us started on the accretion disk. It would roast us alive in seconds. One of the largest supermassive black holes discovered is in the galaxy Messier 87. This black hole has 6.5 billion times the mass of the Sun, and its shadow is so massive that it covers our entire solar system. We've only scratched the surface. There are ultramassive black holes, objects so mind-blowingly massive that they deserve their category. These are black holes that have consumed so much matter that their mass reaches tens of billions of solar masses. Take the ultramassive black hole at the center of the galaxy OJ287, for example. At a staggering 18 billion solar masses, this black hole is so massive that it even has a supermassive black hole orbiting it. Think about that for a moment. An object so huge it's big enough to fit 3 solar systems inside. And now the largest black hole ever discovered, TON 618. This black hole has a mass of 66 billion solar masses. If you could somehow squeeze 11 entire solar systems inside of it, they'd fit comfortably. It shines brighter than 100 trillion stars combined, and it's so far away, we're seeing it as it was 10 billion years ago. TON 618 may very well be the largest known single body in the universe. But here's the catch. It's probably even bigger than we think. Since it's so far away, the measurements we've made are just estimates, based on how it appeared billions of years ago. Now, here's something to consider. While we have cataloged millions of stars, we've only gathered solid data on a few dozen black holes. The reason for this is simple. Black holes are invisible. We can't see them directly. Instead, we study their effects on nearby stars and gas. But even that data comes with massive uncertainties. We only have estimates about their size, based on indirect observations and complex calculations. For example, when calculating a black hole's radius, scientists use the Schwarzschild equation, which assumes the black hole is perfectly spherical and doesn't spin. But in reality, black holes spin, and their shapes are not perfect spheres. This means that all of our measurements come with a lot of guesswork and approximations. So while TON 618 might be the biggest we've observed, it could be even larger, or there could be even larger ones out there, waiting to be discovered. And there you have it, the journey through the largest black holes in the universe, from the tiniest primordial black holes to the unimaginable size of TON 618. Black holes continue to awe and mystify us, and they'll remain one of the universe's greatest mysteries. If you've enjoyed this cosmic adventure, don't forget to subscribe to Astral Passage for more mind-bending space explorations. Until next time, keep looking up.